Hello and welcome, my fellow math mortals. This is STATEQ1. I know it looks like STATEQ1. I'm sorry, it's not spelled phonetically. Okay, we're going to go through this. This is the main menu. We have descriptive statistics, probability, distributions, confidence intervals, sample size determination, test statistics, various test formulas, hypothesis testing, and quit. Let's not quit yet. Okay. So this is great for any kind of stats class. AP stats, I think you guys have access to all the formulas. If it's university or college stats or regular stats, you might not. So let me show you how this can help you. So in descriptive stats, basically the first thing, we've got the mean is the sum of values over, and this is, I know it's a hashtag for the young gen, but this used to be number or pound. So we're going to do number values. So sum of values of number values. The mean from a frequency table is sigma. Now this Greek letter sigma means sum, so it's sum of f times x divided by the sum of frequencies, and x is meaning the specific value. The median for an odd number of values, like say for like 11 or 13 values, it'll just be the middle number. So if you sort ascending in your list, it'll just be that middle value, say for again, for an odd number of numbers, but if you have an even number of numbers, it's going to be the average of the two middle numbers. So the mode is the most frequent value. I know intelligence organizations use this to find out who do you call the most? Who is your most frequently called person or person received called by you? That's your mode. Range is the max versus the min. So like a range of values. Variance is sigma squared. That looks like a little zero with like a toupee falling off or something. No offense to people using hair systems, but that sigma squared equals 1 over n times sigma, again, the sum of x1 minus x bar. X bar means the average, usually with a little bar over the x, but I can't really put that here on the TI84. All that squared. So standard deviation is just the square root of the variance. So we can go to probability. We have a few submenus here, events, permutations, and combinations. And then so for events, probability of E happening is the number of favorable outcomes divided by total number of outcomes. So for example, like let's say you're going to flip a coin one time. So you're just like, oh, what's the probability it lands heads? That's 1, because it can either land heads or tails. And the total number of outcomes is 2, so it's 1 over 2. Probability of A or B is probability of A plus the probability of B if A and B are mutually exclusive. Means they cannot both happen. So the probability heads or tails is half plus half, because you can't have heads and tails simultaneously. That's what it means mutually exclusive. Like one can happen and the other cannot at the same time. But probability A or B is going to be probability of A plus probability of B minus the overlap that they both happen if they're not mutually exclusive. Like let's say, and I'm not trying to bring in rivalries here, but let's say the Lakers win the NBA championship, probability of that, plus the probability it rains when they win the championship. Well, you have to say what's probability of Lakers winning or it rains would be probability Lakers winning, probability it rains, minus probability it rains and they win, because you'd be counting that event or eventuality twice. Okay, enough of that. Okay, probability of A and B basically is probability A times probability of A if they're independent events. Probability of A and B is probability of A times probability of B given A. That's what this means, if A and B are dependent. You can look in your textbook. I don't want to explain that right now. Probability of not A, meaning it's not going to happen, is 1 minus probability of it happening. That's called the rule of complements. This kind of complement, not like, oh my God, your just looks so good. Okay, can we go on? So again, in probability, we're going to do permutations and combinations. So this is kind of funky with the factorial symbol. So permutations formula of none alike, like no items alike, of n given k items. It's going to be n factorial. So like, for example, if I did 3 factorial, that'd be 3 times 2 times 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. That's what that factorial means. Divided by n minus k, that quantity or that difference factorial. Permutations formula, we have n1 and n2 alike, like when you start talking about repeated letters in something like Mississippi. Because it has like repeated I's, repeated S's, and repeated P's, I think, right? And then probability of N, K is n factorial over n1 factorial, n2 factorial times n minus k factorial. And again, if you had like, say, n3, repeating itself, like let's say the I's in Mississippi, that's Mississippi. I'm assuming 4 I's. I don't know. I don't have the word written out in front of me. That would be 4 factorial is the n3. Okay, combination formula is n factorial divided by k factorial times n minus k factorial. So typically if you have like 5 things and like let's say k is 3, that'd be 5 factorial divided by 3 factorial times this 2 factorial. And usually this number factorial and this number factorial, before you factorialize them or whatever it's called, they're going to add up to be the n. Okay, and then factorials I just have right here. It's n factorial is n times n minus 1 times n minus 2 all the way until you get bound to 2 and 1. So these are integer values there. So we go on and let's talk about distributions. Probability and binomial distributions versus normal distributions. So probability and normal distributions. Mean in a probability distribution, mu, that looks like kind of like a cross between M and a U, but it's a Greek letter, so they just call it mu. Kind of like a cross between a cat and a cow. Oh my gosh, sounds like yoga. But it's a sum of x times probability of x. Standard deviation, sigma, equals square root of the sum, big sig, of x squared times p of x minus mu squared. Binomial probability, p of x equals n factorial times p raised to the x times q raised to the n minus x, divided by n minus x factorial. Let me explain. The q is explained here at the bottom. The p is probability of success, and the probability of failure is 1 minus that. So that's what's typically called p and q. Some books and some teachers will have it as p and not p. Some books, some teachers have it as p and q. Just so you know, you got to be able to roll with a different notation. So the mean of binomial is mu equals n times p. I forgot I'll write in the comments what this x, I think it's expected value here. Yeah, that's what it is. Variance of binomial distribution is sigma squared equals n times p times q. Standard deviation for binomial is sigma equals square root of n times p times q. So notice again, standard deviation, square root of variance. So just good to know. And probability of success versus probability of failure, or probability of not p, right there. Oh my goodness. So we did permutations coming. Okay, sorry about this. I'll edit some of this out. Distributions, normal distributions. Okay, z for z-score is x minus mu divided by sig, or z equals x minus x bar over s, depending if we're talking about a population or sample. I'll explain that later. Central limit theorem, the mu of s is just mu, and central limit theorem for standard error is sigma x equals sigma divided by square root of n, the number of items, I think, in a set. So we go on, we talked about distributions. Let's talk about confidence intervals. So we've got confidence intervals. It's not showing, I apologize, on the screen. That's 1p, confidence intervals 2p. So let's do confidence intervals 1p. So we've got a proportion, and this is not fat, this is p hat. So it's p hat minus e is less than p hat plus e. E, I believe, is the margin of error. So e is z, like your z-score, times alpha over 2 times the square root of p hat times q hat divided by n. Mean is x bar minus e is less than mu is less than x bar plus e, where e is t, and this is like for a t sample, I believe, alpha over 2 times s divided by square root of n, where sigma is unknown. Or if sigma is known, it's going to be t alpha over 2 times sigma divided by rad n. And then the variance is going to be n minus 1 times s squared over, and this is a chi symbol. I know it looks like a cursive x, but it's the Greek chi, so it's chi squared right is less than sigma squared is less than n minus 1 times s squared divided by chi squared left. That is a lot, I know. Talk about confidence intervals. Let's do the two-part. So p hat 1 minus p hat 2 minus e is going to be less than p1 minus p2 is less than p hat 1 minus p hat 2 plus e. And e equals, again, we're talking about like the t test, I believe, alpha over 2 square root of p hat 1 times q hat 1 divided by n1 plus p hat 2 times q hat 2 divided by n2. Oh my goodness, that is a lot, and it's been a long time since I've had stats, so forgive me. Sample size determination, oh my gosh, proportion, where p hat and q hat unknown, so we don't know the p hat and the q hat, and is going to be z alpha over 2 squared, and it's actually z alpha over 2, not z times alpha over 2, forgive me for that, squared. That's usually in some kind of table you guys have in the back, front, or middle of your textbooks, times 0.25 over e squared. We usually just use that 0.25 because we assume p hat and q hat unknown. We're just going to assume they're both 0.5, so you multiply them together, you get 0.5 times 0.5 is 0.25. So proportion where p hat and q hat are known, which is cool, it's a little different, it's going to be p hat times q hat here, and just put in the actual values you have for your p hat and your q hat over e squared. And the mean is n equals z alpha over 2 times sigma over e, that quantity squared. So then we go to test statistics. And so for one population, for proportion, is going to be z equals p hat minus p divided by p times q divided by n here. And the mean for one population where sigma is unknown, t equals x bar minus mu divided by s over rad n. And mean one population sigma known, z equals x bar minus mu divided by sigma over rad n. And standard deviation or variance for one population, chi squared equals n minus 1 times s squared over sigma squared. X bar is the sample mean. I'm kind of explaining that for this part here. And then mu, and that's how it's pronounced, mu, the population mean, n equals sample. Okay, my goodness. I believe that was 6. Now we're going to go to 7. Various test formulas. So we got z-test, t-test, chi-squared test. So let's do the z-test first. We got z-test formula equals x bar minus mu divided by sigma over rad n. X bar is the sample mean, and then mu is the population mean, and then sigma is population standard deviation, and n is the sample size. That's what's missing on the other page there. N is the sample size. So we go on. I'm doing the various test formulas again. We'll go to t-test, and the t-test formula for one sample is x bar minus mu over s over rad n, where x bar is a sample mean, mu is a population mean, s is a sample standard deviation, and n is a sample size. So you probably want to look at your book for the difference between population versus sample. Okay, and then we're going to go to the chi-squared test formula. That's also called the goodness of fit test. Chi-squared is sigma O sub I minus E sub I squared divided by E sub I, where df, degrees of freedom, equals k minus 1. Chi-squared test for a contingency table, where degrees of frequency is going to be rows minus 1 times column minus 1. So that chi-squared is sigma O sub I minus E sub I squared over E sub I. Chi-squared, that symbol, looks like an x squared, is a chi-squared test stat. O sub I, O, is the observed frequency for category I, and E sub I, E, is the expected frequency for category I. So they might have 3 or 4 or 10 or 20 different values, just so you know. So the sigma is a summation indicating sum. That's key for everything in stats. That's sigma, just so you know, that's sum, the capital sigma, that is. And df is also known as degrees of freedom. So E is row total times column total divided by grand total. Man, that is a lot. I would hate to memorize that. That's why this program's so awesome. You got to give it a like, a subscribe, or comment. This is awesome, or hey, could you put this in the next iteration of your program? So let's go to hypothesis testing. Null hypothesis. Man, my teacher called it the HO, which is not a dig. It's H sub O. P is some number. The alternative hypothesis. So usually it's an equality. P is an equality. It equals some number. The HA, as my professor called it, H sub A is greater than some number, less than some number, or it doesn't equal some number. So HO is equality. HA is inequality. Greater than, less than, or not equal to. If p-value falls within critical region, the outer area of a curve, then you reject the HO, the null hypothesis. If p-value falls within the middle area, typically, now I'm not talking about two-tailed test or things like that. It gets a little more complicated. This is just the absolute bare bones basics. then if it falls in the middle area, you fail to reject the null hypothesis. So the two options, you reject a null hypothesis or fail to reject null hypothesis. I don't even go to type 1 and type 2 errors. That's something else. So usually if p-value is less than or equal to alpha, you reject the null hypothesis. If p-value is greater than alpha, you fail to reject the null hypothesis. So look, the people getting stats degrees are going to flame me in the comments about this, which is fine, because I know this is not 100% true, but this is just for an intro stats class. And generally, this is the case. But look, take care. Good luck in all your math endeavors. Ciao for now. See you next time. Your source for TI84 calculator programs, mcstutoring.com.